4A. 4A. Okay, so for this week, all we're doing are graphs. We're going to do graphs of all 6 trig functions. Today we're going to start with the graphs of sine and cosine. Yes. Thank you for your enthusiasm. Graphs of sine and cosine. Tomorrow we will practice graphs of sine and cosine. On the block, we will do the other 4. Okay? Yes. And then on Friday, we'll review with a quiz next Monday. Okay, here we go. Letter A. We're going to start with the basics. So basic. Alrighty. Here we go. So here's how we're going to do these. We're going to first start off with y equals just the basic graph y equals sine of x. And yes, your calculator will do this. So to graph by hand, we usually draw a graph like this and a pretty lengthy x-axis. Okay? And the graph of sine, all these points are going to be taken from the unit circle. So if I were to recall the unit circle over here, pretty good, huh? And this is the point 1, 0. And then let's go to pi over 2, which is 0, 1. Over here at pi is negative 1, 0. And then down here is 0, negative 1. Okay? I'm not worried about all the ones in between. So this is what the graph would look like. If I were to go to the first angle, which is 0 radians, what is my my sine value? It's 0. Remember, sine is all the y values all the way around. So 0, 0 would be a point on my sine graph. All right, so then I'm going to go to this one right here, which is pi over 2. So let's put a tick mark. Pi over 2 is my x. And then when I plug in and evaluate the sine of pi over 2, what do I get? The sine of pi over 2 is the y value at pi over 2. So my answer would be 1. Okay, go over here, and now let's do the sine of pi. The sine of pi is right here. What's the value of sine of pi? 0. Okay. Go over here to 3 pi over 2. The value of sine at 3 pi over 2 is negative 1. And then go over here to 2 pi, and guess what happens? You're right back at 0. And then you can keep going around and around and around, but they're going to be the same points. And so the sine wave looks like this. Nice curvy. Okay, don't make them pointy. They're not pointy. Nice curves like this. And it keeps going in, I kind of don't like that. It keeps going in both directions forever and ever. Okay? And that's the sine wave. You what?
Talked about you this week.
To who?
To somebody at work, though.
Oh, okay. Was it okay?
I told him how you started singing that shabby song, though.
Ooh, no, shush, I did not. Okay, it wasn't me. Okay, this is how I graph sine. Now, I just showed you how to do like the whole thing, right, with the points and all that, and you're like, am I really going to do that every time? No, you're not. This is what you do. To graph basic sine, you go like this. You go 1, 2, 3, 4, and that's 2 pi. Okay? 4 tick marks. It's your 4 points around 2 pi. And then normally I would go ahead and label that as pi. This is 1, and this is negative 1. So sine, where I always start plotting my points, sine goes through the origin, 0, 0. My first tick mark, I go up here to 1. My second tick mark, I'm back to 0. It just ping-pongs back and forth between negative 1 and 1, stopping at 0 on the way. My next point, negative 1. Then I'm back to 0. Okay? That is what we call 1 full period of pi. The book asks you to do 2. I'm okay with 1. And that's the graph of sine. As long as you know that it just keeps going over and over and over, the same thing. Okay? It doesn't stop right there. It's not a cubic function. It actually will keep going forever and ever, up and down. Pi is irrational, yeah. But that's a really easy way just to graph those. Okay, let me show you the graph of cosine now. Here's your basic y equals cosine of x. Now, these are your parent functions, by the way. The sine one we just did, the cosine. So what are we going to do with these parent functions? We're going to shift them up, down. We're going to reflect them. We're going to do all kinds of crazy stuff to them. But these are just the basics that you have to have down. So here's what cosine looks like. And these points are all taken from, I'm not going to go around the unit circle again. You'll just have to, believe me. So I'm going to go 1, 2, 3, 4. And that's 2 pi, and that's pi. And then here's positive 1 and negative 1.
We really have to draw 1/2 of it, right?
Yeah. I mean, you can keep going in both directions. All right, thank you. So, if you were to go to the unit circle, what is the cosine of 0? What's the x value at the angle 0 radians? It's 1. The x value is 1 there. Okay, so cosine, I always start by graphing up here at 1. Once you have that point, you're good. You have the rest of it. The next tick mark, you're going to be at 0. The next one, as you go along, you're down here at negative 1. Go to the next one, you're back to 0. And then go to the next one, you're back at 1 and you start over. You see that? And so your graph would look like this.
Oh, so it's not a V, it's just...
No, they're all, sine and cosine are the same graph, they're just shifts of one another. Okay? That's cosine. Now, if I graph them on the same, sorry, did you guys still need that? If I graph them on the same graph, okay, here they are. See, they're just shifts of one another. They're exactly the same. Now look, do you see where they intersect? Right there. Do you know what that point is? Do you know what
It's a fourth of pi.
it is? It's a fourth of pi. Okay, watch. Hit trace. Plug in pi over 4. Do you remember what they both equal at pi over 4?
Whoa.
Rad 2 over 2. That's 0.707. Right? Around the unit circle, they're exactly the same, rad 2 over 2. That's where they intersect. Cool, huh?
So cool.
All right. So now let's talk about some basic things for this, okay? Because we're going to change the whole thing up coming up. All right, so graphs of sine and cosine, they're going to look like this. Y equals. Y equals. Now, sometimes they're going to have a negative symbol out front. Okay? Talk about what that means. Sometimes they have a number in front of them. We'll call that A. Then here comes the function, whether it's sine or cosine, either one. Then we'll have B times x minus h plus k. All right, that's a lot to write down in one thing, isn't it? Okay? So let's talk about what all of these things mean. First of all, this negative symbol will tell you to reflect over the x-axis. Reflect over x-axis. Okay? This A right here, that A in the front, that is going to be the absolute value of A is called the amplitude. Okay? The amplitude. Now the one that we just did, y equals sine x, just your basic sine has an amplitude of 1. What that means is from the center of its graph, it's going to go up 1 and down 1 from there. So if I put a 2 there, guess what's going to happen to my graph? It's going to go up and down to 2 and negative 2. So for example, I'll show you on here, insert a 2 sine x. It basically, see, it goes all the way up to 2 and negative 2 now. So that's what the A does there. All right, that part B right here, this B.
So the A is like a stretch?
It is. B is going to be what your period's going to change from B, okay? So B is going to be a period change. Now the period of a sine and cosine is normally 2 pi. See, what a period is it goes through one whole cycle and then it cycles again and cycles again and cycles again, okay? So when it goes through one full period, then you're done. So B is going to help us. Now, it's not always going to be 2 pi. So the period of a sine and cosine graph is always going to be 2 pi over B. That you need to memorize right there. Bless you. Yeah, I know, right? And then finally, H is going to be a horizontal shift in the opposite direction. Horizontal shift. X is the variable, yeah. Opposite direction. So we'll look at that. And then K, I ran out of colors. K is going to be a shift up or down in the same direction. Up or down shift. Just like if you had, you know, a number inside your parabola that shifts the opposite direction and the number on the outside shifts it the same direction up or down. Okay, are you ready to do some of these? All right, let's just like not do all of the changes at once. Let's just do a couple of changes, okay? So part B, we are going to do some translations. So you need to know your parent functions for sine and cosine. Okay, you need to know that sine goes through the origin and cosine goes through the point 0, 1. Once you have that, you're pretty good. Okay? All right, so here we go. Let's do just a number 1. Let's do y equals -3 sine of x. -3 sine of x. Okay. Now, you can draw the parent function if you want to. I usually do if I'm shifting left or right, just so I know what it is and I shift everything after that. This one, I don't think you really need to draw the parent function. You can, but you don't need to. So here's what I do. Okay? First of all, I would say that the amplitude is 3, positive 3, okay? Amplitude's always positive. It's the absolute value of A. The period here is going to be 2 pi over B. B is going to be the number in front of X. Right now it's 1, so the period's still 2 pi. The period did not change. And then I know that I have to reflect this over the x-axis. Okay, so knowing all those things and having those in my head, I can go ahead and graph. Here's how I graph. I go like this. 1, 2, 3, 4. I count 4, and I put whatever the period is at that 4th tick mark. Halfway in between is pi. Okay. My amplitude is 3, so I'm going to count 1, 2, 3 up, and 1, 2, 3 down. And when I grade these, when you guys take your quiz next Monday, I look at your x-axis and your y-axis. All the graphs are going to pretty much look the same. Our x and y's are things that are really changing. Okay? So you have to label them. All right, so now let's graph sine. Sine's going to start right here. It doesn't really start there. That's where I start graphing it. But I graph it starting there. And then the next tick mark, I'm going to be at -3. Right? Normally, sine, I would go up to +3, but see, it's a -3. So I'm going to go down here to -3. Then my next one, my next tick mark, I'm back to 0. One more tick mark over, I'm up here at +3, and then I'm back to 0. And that's going to be one full period of this graph. And so you graph down and up. There we go. And make sure you put arrows to show that it continues to go. Fun, huh? Isn't that fun? Okay, now let's look and see what a period change will do. Number 2. Y equals 2 cosine of 2x. Ooh, a couple of changes. So I changed the amplitude and I changed the period on this one. Okay? So my amplitude is 2. And the period is 2 pi over b. In this case, b is 2. B is always the number in front of x. You know how we wrote it with the parentheses and all that stuff? It's still next to x. If you were to distribute that b, it would be next to x. And so the period of this graph would just be pi. So let's graph it. Here we go. Go to your graph, and now you're going to label the x-axis. You're going to count 1, 2, 3, 4, and our period has now shrunk. It's normally 2 pi. Now our period is pi, so I'm going to label my 4th tick mark as pi. Okay, so like I said, your graphs are going to look the same pretty much every time. It's just your x scale and your y scales are changing. So then halfway, this would be pi over 2. I'm going to count up 2 and down 2. All right, and once I have that, now I'm ready to graph cosine. So let's graph our parent function of cosine. Cosine normally starts at 0, 1, but I'm going to start it up here at 2 because the amplitude has changed. And once you know that point, you know the rest of them aren't so bad. So my next tick mark over, I'm at 0. It's just going to bounce between 2 and -2 the whole time. Go to the next tick mark, you're down at -2, back here to 0, and up here to +2. Okay. Make sure you round this when you graph it. You don't go up with it because it comes back down, and it looks like this.
So anytime that we're graphing the functions for like cosine at least, like you always know like it's going to be the top tick mark.
Yeah, except when we shift, we're going to do a shift left and right too.
Why do you start at 2 and not 0, 0?
Because that's the sine graph that starts at 0, 0.
Okay.
Sine and cosine are different. So you go back to your parent functions. You have to know these. Cosine, its basic parent starts there. So when I change anything, I have to change that. Yeah. Okay. Yeah.
So what's the point of doing the 2 pi over b?
So this graph, if I were to graph it on a normal, say a normal graph, like I'd go 1, 2, 3, 4, and if that was 2 pi, and this is pi, this graph is actually going on in here. It's like it's all stretched down. Like that's a really bad graph, but if I were to graph it on 2 pi, it would be like a few of them, 2 of them, really. So that changes the period. The period is now, see, normal cosine would be 1 full period is 2 pi. But then since my period has now changed just to pi, then 1 full one of them happens in there. And then another one would happen there to 2 pi. So that's what changes. It just doesn't look different because we draw it and we label that as pi instead of 2 pi now. It just makes it easier for us to graph them. All right, let's do another one, number 3. Another one. All right, let's do y equals 3 plus 5 sine x over 2.
Is there part C?
No, we're just going to do these now. I teach you all of it in kind of one thing. I used to just do, okay, here's the period, how that changes. Here's how this changes. And I used to do it like, but now I just throw it all at you and then we just do them.
It's just like regular graphs. So like,
Yeah, they are. It's just like, here's your parent function and now let's change some stuff. Okay, so here we go. We got to talk about this one. This one has an amplitude of 5. The amplitude of 5. But do you see that 3 in the front, 3 plus? A lot of people don't like it written like that. It's the same thing as writing y equals 5 sine of x over 2 plus 3. Sometimes they'll put it in the front though, okay? But all that is that's a shift of 3 up. We're going to shift up 3. I'll show you how to do that. And then the period has changed. The period is 2 pi over b.
1/2.
Yes. Did you see how b is 1/2 here? b is not 2. We already did one with 2x. This is 1/2 of x. So yes, so the period is 4 pi. So normally when a graph would go through the cycle in 2 pi, it's being stretched out so that the whole thing has to go through, and it takes 4 pi to go through one period. Whew, it's a lot going on this one. Okay, so let's graph it. Here we go. Here's what you want to do. Give yourself some room up top. So first I always start with the x-axis, figuring out what that's going to look like. So I would go 1, 2, 3, 4, and I would label that as 4 pi now. In the middle, halfway, is 2 pi. Half of 4 pi is 2 pi. Okay, so whenever I have a shift up or down, what I like to do is I like to create a new axis. So I'm going to go 1, 2, 3, and I'm going to do some dashes there. That's my new axis. Okay? From that 3, I'm going to go an amplitude of 5 in each direction. So what's the highest my graph is going to? Not 5, 8. See, my new axis is the y equals 3 line. And so that's like my new 0, my new x-axis. And my amplitude is 5 above that and 5 below that. So I would go down 1, 2, 3. I would be down here at -2. So I'm up here at 8, down here at -2. Okay. Once I set up my graph, now I'm all set to graph
How
sine.
many points do you get for that?
Most of it.
Okay.
Yeah. Okay, so sine, this is your basic sine graph on this new axis over here. So now I'm going to start sine at this 0, 0 point, right? Normally it would be down here at 0, 0, but everything's being shifted up 3. That's.
If you were cosine, where would you start?
If you were cosine, where would you start? That is a great question.
8.
8.
Okay.
Yeah.
Is it always for cosine? You always go to like the highest.
The highest,
point
yeah.
On your y.
Unless it's negative, then you would start at -8. Yep. Okay, so now my next tick mark, I'm going to go to the highest point because it's positive. And then I'm back here to 0, like pretend 0. Not the real x-axis, but the new one that I've created. I ignore this line, this x-axis, once I've done this. And then I'm down here at -2 on my next tick mark. And then at 4 pi, I'm back to my new x-axis of 0. And then you graph it. There you go. And then I could ask you, what's the domain and range of this graph, right? We get to do all the fun things for graphs. Domain is going to be nice for sine and cosine. Do you see any breaks in the graph at all? No, it's a continuous, beautiful, curvy function. You're going to use it in calculus. You're going to take derivatives of it, integrals. It's very exciting.
You don't want derivatives this year?
No, you won't. Yeah, at the very end we do.
Everybody talks about how amazing
They are. Derivatives are life changers. All right. All real numbers. What's the range on this?
Greater than -2, less than 8.
Or equal to. So there's 2 ways to write that. You can write it in interval notation, -2 to 8. How many of you guys like to write it that way? Yeah? I do too. Or you can write -2 to 8. Either way. Yeah? People mess up on this because they forget y is range and they'll write x on accident and they'll get it wrong. Yeah, fun time. Okay, let's do now. I know you feel like you're done. We've only done 3 problems. Let's do a shift left or right. Those are tough. Okay? Are you ready? Yes. Let's do y equals, I'm not going to change anything else. I'm not going to change the period or the amplitude. I'm just going to do a shift. Y equals cosine of x minus pi over 4. Okay? This is your basic cosine graph. Just shifted pi over 4 to the right. Right. Okay, so we're going to shift pi over 4 to the right. The period is still 2 pi. It's 2 pi over b. B is the number, the coefficient of x, which is 1. And the amplitude is 1. Okay? So with shifts left and right, I usually graph the parent function. I mean, sometimes. It depends. If there's a lot going on, I'll graph the parent function. This is
I'm sorry, what's RT?
to the right.
Oh, okay.
Yeah, we're going to shift pi over 4 to the right. All right, so our period is still 2 pi. So let's go 1, 2, 3, 4. And we'll write 2 pi there. Pi there. Amplitude is 1. There's no shift up or down. 1 and -1. Now, this thing, we're going to shift it pi over 4. Okay, I have to figure out where my pi over 4s are at. What's this tick mark right here? Pi over 2. Okay, it's half of pi. It's in between 0 and pi. So all the pi over 4s are going to be all the ones in between here. The worst is when they shifted pi over 3. You will hate that. I try not to.
Okay.
Yeah. I'll shift pi over 4, pi over 2, or pi, you know, the nicer numbers. All right, so here we go. Normally, our cosine graph, basic cosine, would start right here at 0, 1. But I need to shift pi over 4 to the right. So I'm going to shift this little tick mark right here. Okay? My next,
So then, do you go to the next tick mark? You don't go to like the point?
you're going to all of these now.
Yeah, so you go to the tick mark, you don't go to the point.
Right.
Okay.
So now the next one, which would normally go through pi over 2, you have to shift that one over here. But if you put your tick marks in, then you can see them. That's pretty nice, especially when they're in a different color like that. Then I'm going to -1 at this blue tick mark. And then back to 0 here. And then back up to 1 at the tick mark right after 2 pi. All of those, and you can graph the parent function if that helps you. You can graph it and take all of your points and just shift them over pi over 4. So then it would also go through here. Okay? Pi over 4 sucks. I would have rather have like shifted pi over 2 or something. All right, let's do one more.
Last one?
Yeah. And you'll have some homework, and I have graph paper over there again if you need it. All right, so let's do y equals -4 cosine of pi x. -4 cosine of pi x. Okay. This one has no shifts up or down, so that's kind of nice. The amplitude is 4. And the period is 2 pi over b, which is 2. Okay, that's kind of weird, right? It's okay. We're in charge of our x and y scale. Bless you. We get to do this. 1, 2, 3, 4, and label that as 2. Halfway would be 1. It's not 2 pi, that's totally different. I noticed some people, like, when they got answers like 2.2 radians, they put in a pi for some reason. There's no pi there, it's just 2.2 radians. Okay, and then 1, 2, 3, 4. 1, 2, 3, 4. So +4 and -4, and now I'm ready to go.
But it's split, right?
Yes, it is flipped. So normally cosine, which would start up above at 1, is now going to start down here at -4. Okay? And then once you have that, then you can't go wrong, right? The next tick mark, you're at 0. So you're at the lowest, and then in the middle you go to 0. The next one you're at 4. Back to 0, down to -4, and you've gone a whole period in 2 pi. And so when you graph this, yeah.
Are you gonna mark us down if our graphs don't look like curvy enough? If they're too like
If they're pointy, I have been known to mark people off for that. They're not jaggedy at all. Because if they're jaggedy, then there's no derivative. Oh yeah, round those out better. You can practice though, you'll be all right.